Hi everyone, my name is Kevin George Buhain, student ID 10150526, and I will be presenting my assignment 2 for COMP3122. So first off is I'll start with the part A, um, making a decision tree model using my COVID data CSV that I downloaded from Kaggle. So we created a Panda and then imported the train test split, decision tree classifier, and grabbed the accuracy score for the metrics. So we used our COVID data set from Kaggle, like so, and then selected three features, which is age, pneumonia, and diabetes for our X features. And the target is the classification final. Um, so 1, 2, and 3 are positive in COVID, and 4 to 7 is negative. So we change all inputs of 1, 2, and 3 from the column classification final to positive to 1, which means they are positive, and 4 to 7 we change it to 0 to make them negative for Y. So here I'll explain why we selected the three features for X. So why we chose age, pneumonia, and diabetes, because they are a good classification for when we think who are susceptible to COVID. In example, if you are age 65 and you are positive with pneumonia, but you are negative with diabetes, there's a chance that you are already positive. As you can see here, since we remember that our 1 to 3 outputs are positive, and then there's also, if you are negative with pneumonia and you're 55, you can with diabetes, there's a chance that you are also a positive in COVID. But if you are negative in pneumonia and uh, negative in diabetes, when you're age 53, you are negative with COVID. There's also chance though that even if you are negative both of pneumonia and diabetes and you're age 38, you can still be positive with COVID. So what we wanted to check here is um how like what are the chances for with different ages with no pneumonia or diabetes to have positive COVID test, and with older ages with other ages with positive pneumonia and negative diabetes to have positive COVID test, and vice versa. So we train split by 30, so we chose 70% to train and 30% test. That's why our test size is 0.3 and a random state 42, because 42 is answer for everything. That's that's a joke. I don't remember where it was from, but yeah. Then we use our decision tree classifier. We fit our model X train, Y train. That means 70% of the data set and 70% of the target. Sorry, 70% of the features and 70% of our target. And then we grab our prediction by model predict, and we use our 30% test features, then check the accuracy based on the the test that we have and the prediction. So finally, we print our accuracy, which is 66%. So that's the part A for our decision tree model using COVID data.csv. Next is working with pandas using assign to CSV. So we read our CSV again, grab our details. Then one is permanently delete the model column. So we do that by dropping the column model right here. So if you notice here, we have 8 columns in total. And then after dropping the model, we check our model info, and our data frame. And then as you can see here that we have 7 columns left uh, without the column model for the new one. Then we remove all the commas, what do you call this? $, and the brackets, $, and another closing bracket from the cost column, and check the data type. There you go. So the data type is 0. Convert the cost column to integer. Now the data type of the cost column is 64. Check the average of the cost column. So we use our built-in function mean. And as you can see, we have an NP float 64. That's the data type. It's a float. And then our mean is 54.626. The average cost per continent, grouped by continent right here, and then followed by our cost. So this is the average, the mean for each, what do you call this? Each continent. This is the average cost for each continent. Then we make a bar chart, mean of numerical columns grouped by continent. So we use the built-in function from df instead of matplotlib because we already have, since it's easier that for the data frame to make this a bar chart compared to a matplotlib, and matplotlib doesn't really read from data frames. It needs a list, and there's more manual processes that we need to do to make a bar chart using matplotlib compared to the built-in that we have from the data frames. So we group them by continent with the numeric value of mean, then the bar type. Six is how many times each continent appears, value counts. 7, unique display unique content value and count. So this is our unique continents, and then 7 is the number of unique continents. Let's see, value counts on cost plus explanation. So this histogram of the cost column. So the bins here means there will be 50 bars right here of the cost. So that's 50 different costs find missing values in zip code and type. So we find the using this code right here, we find um, the null data from zip code and type. Then we submit. So as you can see that we have two null from type column and then 9 from zip code column. Show type statistic not a number, then replace with x. So from here we describe everything, and then for the df type with NA, we replace it with XXX. Lastly, we print those data that have a type that is XXX. We drop all rows with any missing values, count the remaining rows. So from 950, we are now down to 939 data or rows. And wait, okay, 950. Yeah, from 950 we are down to 939, and then use the describe and fetch first row and third column. So describe our data frame and print it. So and then last is we find the value from the first row here and third column right here. That means 950 right here at the end. And then sort our value counts of continent by frequency, then alphabetically. So we take our column of continent and then grab its counts. We sort by the index, this once, and then sort values ascending by name. So this is my COMP3122 assignment 2 presentation. Thank you for watching.